All right, I'm going to start with number one here. What is the quotient of all this? So what is the quotient of all of that? And let me copy this so I can do all three of these problems with us. Last class, I taught you two ways to find a quotient. I taught you long division, and I taught you synthetic division. Which one was the shorter, easier method? Synthetic. And if you're looking for synthetic or wanting to use synthetic, I told you on the divisor, you must be able to solve it for x equals 0. Could we solve this divisor here? So I'm going to label d of x. Could we solve this if we said x equal to 0? Could we solve that? Yes, we could. So you would first add over the 5, and then how would you get rid of a 2 that's multiplying? Dividing. So we'd have x equals 5 halves. Said another way, inside lies. Since I have a minus 5 here, it would become a positive 5. Since I have a multiplying by 2 here, it becomes a division by 2. So we're going to divide all this by 5 halves. Now, 2, 4. With synthetic, there's a couple things you need to make sure of that are very important. One is that you don't miss a power here. Your power should count down sequentially starting from the largest power, the degree. The degree here is 4. So I should go 4, 3, 2. This would be a power 1, and then no power. I have them all, so I don't need any placeholders of zeros. Like we saw that last class, we need a placeholder. So I fill it in. 2, negative 3, negative 13, 36, and negative 45. What we do is we take this first term and we drop it straight down. And then, as Miss Lester says, we do MAMA. That is an acronym. It stands for multiply, add, multiply, add. So I multiply this. 2 times 5 halves. The same thing as 2 times 5 divided by 2. What is 2 times 5? 10. Divide that by 2. 5. So now I add these together. 2. Very good. And so now I have a 2 again, so I should get the same value. Another 5. 2 times 5 is 10. Divided by 2, we got 5. Now we get a negative 8. Now we're back to multiplying. Multiply here. Negative 8 times 5 is negative 40. Divide that by 2. Negative 20. Negative 6, positive 16, sorry. 5 times 16, if you don't know, what's 5 times 10? 50. What's 5 times 6? 30. 50 plus 30 is 80. And then you divide by 2, you get 40. I agree. Negative 5 there. That is our remainder. We learned last class, if you have a remainder, it is not a factor. If you were typing in your answers on the Alex, you leave the remainder separate. That would be its own answer. As for the quotient, this portion, what's tricky about synthetic is it's not always the answer shown you. So it looks like after I drop power, this would be x cubed, this would be x squared, this would be x. But this isn't actually our answer. Because on the divisor, if you have a coefficient here, or said another way, if you were dividing by a fraction, you take your denominator and you need to divide each of the quotient portion by that denominator. So since my denominator is 2, I need to come back and divide everything by 2. You might be wondering, why do I need to do that? Well, because we're supposed to be dividing by 2x. And when I started this problem, I didn't divide 2 by 2 and say, oh, that's, or I didn't say 2x4 divided by 2x, that's x cubed. We actually just wrote it as 2, like the 2 dropped. But we need to divide all these by that coefficient of 2. So that's what's happening right here. I divide all of these by the coefficient of 2, and I'm left with x cubed plus x squared minus 4x plus 8. Now the remainder, you want to touch with that 2, you want to divide it by the 2 because whenever you write your remainder, you put it over the divisor, 2x minus 5. So there is the division of 2 right there. And that would be your solution. That's it. just to label the pieces here to make sure we're all on the same page. Technically speaking, this portion is what most people refer to as the quotient. This portion right there is what we refer to as being the remainder. And this portion right there is the divisor. That's the three pieces that make up this one answer. We have the quotient, the remainder, and the divisor. Would it be helpful to see this again? Let's see another one.
Okay.
Let's try this one more time. Number 2. What is the quotient of these two things? So first, you start with what does x actually equal if you were to solve it? Not 2, try again. -2. Because inside lies, very good. So if you were to solve that for x equal, or the divisor equals 0, we would get -2. And so we're dividing by that -2. I check, are my powers decreasing sequentially? 4, 3. Ah, we skipped one. We skipped 0x squared. So in this place right there, we should have a 0. So when I write this out, I'm going to have 1x to the 4th minus 1x cubed, a 0 for x squared, a 2, and then a 5. So drop down to 1. 1 times -2 is -2. Again, I'm going to follow mama here. I'm going to multiply, add, -2, -1 combined to be, okay, -2 times -3 is a +6, I agree. And we get 6, multiply. Another, then we're multiplying this time. 6 times -2 is -12. 2 minus 12 is -10. And finally, +20. So when I add these together, I get 25. That right there is the remainder. This portion would be the quotient. We started off with x to the 4th, which means this is x cubed, x squared. That's an x. This doesn't have a symbol, so you put a plus there. If you were going to write your answer as one combined unit, you would say x cubed minus 3x squared plus 6x minus 10 plus the 25 over the divisor of x plus 2. This one, I do not need to divide because there's no coefficient in front of the x. If you want to treat it as a coefficient, it's 1. You divide everything by 1, but that doesn't change the problem. So this right here would be your solution. So that would be the solution there. Before I move on, I just want to show you. So the 25 came from the 5 plus the 20 at the end. The 5 and the 20 right there is where I got 25. You add those two together. And I got the 20 by taking -10, multiplying that times -2. That's a +20. I want to show you graphically this. We have this equation right here. Can y'all read that off to me real quick? X to the 4th. What was the rest of the equation?
Oh, x to the 4th minus 3 minus x cubed plus 2x.
Minus x cubed? Okay.
Plus 2x. Plus 5.
Okay. We wanted to take this equation right here, and we wanted to divide all this by x plus 2. And so if you zoomed way out, you would see a -2, there's a break in this graph. So that's because you're not allowed to divide by 0. So I got to think through here. Let me change this. Let's make this a -5 and this a +5. There it is. So you can see This break is at -2 because you're not allowed to divide by 0. Now we found the solution to be x cubed
X cubed minus 3x squared. Plus 6x. Minus 10.
And I want to stop there. I'm not going to put the other part in, and I want to show you how these graphs are similar. Isn't this kind of neat? Check this out. Look at the green from the purple. What's the only difference? It doesn't have the infinite asymptote or the infinite discontinuity. Because you're not allowed to divide by 0. When I've just typed in this portion of the answer, do I have any division there? No, so there's no domain break. Now, if I then come back and add, what was it, 25 over x plus 2, now I get the same graph because I added in, you're not allowed to divide by 0. And so now I'm going to have a break at -2. You see how that worked? Isn't that kind of neat? So if you take the quotient apart from the remainder, if you separate them, like kind of the way Alex does, what you're doing is you're finding the answer with the infinite discontinuity removed. That's what happens. Isn't that kind of neat? A little bit? Maybe not. Maybe it doesn't entertain you, but that I think is just fantastic math. I think that's pretty impressive. So that's just me though. My goal by the end of this year is that you look at the math and be like, oh, so impressive. That's pretty cool. All right, let's check out number 3. Because we have a full deck today, on number 3, I'm just going to show you the technology way of solving this type of problem only, no algebra. What does this symbol mean right there? Inverse.
Switch x and y. Inverse.
This problem is saying find the inverse given this function and state its domain and range. What do I want you to associate in your brain? When you hear inverse or see this symbol, what do I want you to trigger in your brain? Not opposite. Switch x and y.
X and Y.
Switch x and y. So the technology way of answering this problem is to say, okay, f of x, that represents y. I can graph x equals 2 divided by y minus 4, and I'll know what the solution will look like. I'll also know the domain or range from the graph. So that's what I'm going to do here. I'm not even going to do the algebra. I'm just going to type that part in. X equals 2 divided by y minus 4. Was that what it was? Yeah. I need to go home here. There's the graph. And so if you were taking a multiple choice exam, I don't care what it was. If it was AP Calculus BC, I don't care. You could just graph your answer choices and see which one overlaps. That's the technological way of getting an answer if it's multiple choice. If it's not multiple choice, like on Alex, you'll have to do your algebra. But from here, let's talk domain. If I want to see domain, does this graph go forever to the left? Does it go forever to the right? Is this one connected, continuous piece, or is there a break in the domain? There's a break. Value has pieces. I agree. Right here at x equals 0, we have a break, which means the domain will not equal 0. That's our domain. Or you could write it, if you want to use interval notation, as -infinity to 0 union 0 to infinity. It doesn't hit the 0. That's why it's not a bracket. And the left side, this left piece, breaks at 0. This one starts at 0. That's why you can write it this way. Now let's talk range. The range is you're looking at y values. Does this go down forever? Does it go up forever? Is it connected everywhere in between? No. Where's the break? This way. Y equals 4 is where our break is. So if you were going to write your range, you would say, since that's the break, you would say y cannot equal 4. That blue line, the graph doesn't actually equal it. That's why it does not equal there. That's the difference. Or if you want to write the other way, you could say it goes from -infinity all the way up to 4 without touching 4. So parenthesis on the 4. Union. This piece goes as low as 4 and as high as infinity. There would be your range. Questions over the bell ringer?